So the other issue, the other subtopic under the same topic we are looking at, which is under symmetry, it is the issue to do with rotational symmetry. So we are told that if a two-dimension shape has a rotational symmetry, it will have a center of rotation, but a three-dimensional object will have an axis of symmetry. I mean axis of rotation. If the two-dimensional shape has a rotational symmetry, it will have a center of rotation. But a three-dimensional object will have an axis of symmetry. Now, what do we mean by saying a three-dimensional object? A three-dimensional object, those are objects such as the cube, the pyramid, or the sphere. The cube, the pyramid, I mean the three-dimensional object. 3D or 3Ds. We have the cube, okay, the cube, what else? The pyramid, which is to depend with what kind of pyramid am I making there. So this is another pyramid, which is a rectangular pyramid, etc. And also the sphere. Those are what? Those are three-dimensional objects. These are three-dimensional objects. So from the previous video, we were looking at the two-dimensional shapes, of which we looked at the rotational symmetry order, or the order of rotational symmetry, where we had found that, for example, we had a triangle, which is a two-dimensional object. It has a three symmetry or rotational symmetry, and we also had a rectangle, where we said the rectangle has two rotational symmetry. So now we look at the three-dimension, where we are going to have the example. So the example is as follows. So we see how best we can answer this question, looking at the rotational symmetry of the three-dimensional object. So this is the example we have. We have this cube. The question is, find the number of axes of symmetry of a cube. So maybe to quicken up things is that when I find the axis of symmetry, we use the formula which is n plus 1, where n means, or I will say where n is equal to number of sides. So when you look at that cube there, it has got how many sides? That cube there has got how many sides? So let's count the number of sides. So the number of sides, we have got side, maybe I just name them. Side A, B, I'll say comma, side A, AD, comma, side side DC, I'll say comma, then I'll come to side CB, comma, what other side do I have? We have BF, comma, side FG, comma, side CG, we have side CG, comma, what other sides do we have? We'll go to side AE, comma, we have side EH, comma, we have side HG, comma, we have side FE. Did we have FE? No. I'm sure these are the sides we have. Do we have FG? Yes, we have. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's one side which is remaining. What side is? So we are the side which is remaining, and this side is D, D, and H. These are the sides. So we have how many sides? The total sides are 12. So these are the numbers of sides which this cube have. So in this case, what are we trying to say? We are going to use the formula N. We are going to use the formula N plus 1. So we find the number of rotational sides. N plus 1, where N means number of sides. So in this case, we are going to have 12 plus 1. And our final answer will be 13. So this cubeboard has 13. Okay, this cubeboard has 13 axes of symmetry. It has 13 axes of symmetry. Axis of symmetry. You may come across such kind of questions in paper 1. Instead of identifying them, like from this side to this side, you draw a line. Again, you say, maybe I use another pen. You draw a line there. From this side there to this side here is another, it's an axis. Again, from this side to this side, you can draw another line. Then again, you can come from this side, this face here, to that face at that other side. Okay, you draw again another face to there. You do this. What else? So far we have drawn. Then again we have, you can do again from this center here up to there. Again you do this. From there up to here. Again from here up to, it can come up to here. You do all those rotation or axis symmetries. You find that you are going to make 13 of them. Now, instead of doing that, you can just use the formula which says N plus 1, where N stands for the number of sides, not the number of faces, but the number of sides. So how many sides are here? We counted today are 12. So 12 plus 1, this is why we are having 13 as our final answer for the rotational symmetry of that cube. Thank you so much.